In this exercise, we're going to draw classification points. So I have A, B, C, and D. And then we're going to train classifiers for supervised learning to be able to distinguish between these dots. So I've generated these in a Jupyter notebook just by drawing with my mouse or with a pen, and I can draw any shape or configuration I'd like. If I'd like to add more points, I can continue drawing here, make it a little bit more dense, and then copy the CSV. So let's go through this exercise. I'll show you how to install and use this draw classification notebook. Come here to the website for machine learning for engineers for draw classification. I'll put a link to this in the video description, and come here to this IPython notebook. You can also come down here to Google Colab if you'd like to use it here, although the drawing isn't going to work because you can't copy to clipboard at least easily in Google Colab. If you have ideas about that, how to make that happen, I'd love to hear your comments. Okay, so I'm going to come here to this draw classification on GitHub, and then we're going to select the raw, right click, and I'll do save link as, and just go ahead and download that notebook and open it up with Jupyter Notebook or Jupyter Lab. All right, so we have this draw classification notebook. We're going to create this interactive drawing capability to draw the data set that we'd like and then be able to do classification on this. Okay, so the very first thing we're going to need is to pip install draw data. So chances are that didn't come with your Anaconda distribution, and so you have to run it. It's going to get all of the dependencies, which are quite a few. And then once that has run and it's installed, go to kernel and restart your kernel just so it is able to use that package. And then you can comment this out. And so you only need to do that once. Now let's go ahead and create our data set. We're going to go from draw data, we'll draw scatter. And if we run this, now we'll get this template like I was showing before, where we can create, all right, these different points. I'm going to draw a few more here. Here's going to be the B section. So go ahead and just draw these however you'd like. They can be overlapping or not overlapping in whatever shape or configuration you would like. All right, so here are my data points. Now what I'm going to do is just select copy CSV. You can also download the CSV or download JSON file or copy JSON, or you could reset it as well. But I'm just going to select copy CSV, just copy it to my clipboard. Now what I want to do is read the data. So after I've selected copy CSV, I'll import pandas and I'll read from the clipboard with comma separated values. And then I'll sample just 5 of those just to show what it generated. Okay, so I see the X, Y, and Z values. So X is the X position, Y is the height, okay, and then the label for each of those. So I just sampled some of these. I have A, B, C, and D, as you can see from the different colored dots. And I've generated that just by drawing on my notebook. Now what I want to do is just describe the data. Let's just look at the number of data points that I have. I have 800 data points. You can see the mean, standard deviation, and then the quartile information for that data. Now we want to go in and visualize the data as well. Let's just look at this. I'll do this with Seaborn in Matplotlib. Let's generate a pair plot, and then I'll show the plot. So here it is just with the distributions. You can see just the distribution of each one individually, then on a pair plot, how they relate to each other. So this just replicates what I already drew, but just shows it in Seaborn. All right, let's encode the data, because in classification, I can't use A, B, C, and D. I have to convert that to numbers like 0, 1, 2, 3. And so to do that, I'm going to use the the pandas factorize, and I'm going to factorize my z, which are, if I scroll up just a little bit, I can see here z is going to be that label, A, B, C, or D. Now what I'm going to do is just go ahead and sample from that. You can see I've converted the z values into numbers. So using an ordinal number encoding, and there are links to each of these if you need additional help on, for example, feature engineering, or on this one right here, identify data quality issues and data cleansing. You can also come here for statistical overview and summary statistics. All right, I'm going to come down here now to scale the data. Next thing we need to do is use something like a standard scaler, and this is going to convert it to a mean value, an average value of 0 with a standard deviation of 1, and I'm going to transform that data. I don't want to transform the z values because those values are need to remain integers. They need to remain categories. And then I'll add the scaled values to the data frame, and then we'll sample it again. Okay, so I can see I've added just 2 columns now, x scaled and y scaled, and those are scaled from these larger numbers here to something that's mean 0, standard deviation 1. All right, now I want to split the data, and there's some help on splitting data as well, and do 80% and 20%. Okay, I'll use the train test split function, and I'll take my data and I'll split it into 20% for the test. And I'll say shuffle equals true, so I'm not just taking my data from the first half, it's randomized. All right, now what I want to do is just import supervised learning packages. And there's some Scikit-learn documentation. It makes it very easy to run classification on these. I'm going to just use supervised learning classifiers like logistic regression, Gaussian naive Bayes, the stochastic gradient descent classifier, k-nearest neighbors, decision tree, random forest classifier, support vector classifier, and a neural network. All right, so let me just run this one on the train test split, and then come down here and import these packages. Now I'm going to create the models. I'll initialize the classifiers, and you can put in the hyperparameters here, the options on each of these, but I'm just going to create these models for each of them, and then create a list of them as well with their names, so that I can so that we can print them out and cycle through this list very easily for fitting and training. All right, so there is the initialized classifiers. I'm also going to train the classifiers now with just going through this list with each classifier and each name in this classifiers list. And so for each one, I'm going to take the classifier and I'm going to fit it with the X and Y data, and then the Z for the training, okay, for the label. And so let's just train all of those classifiers. Some of these, for example, number of iterations, limit reached, okay, logistic regression. So if that is a problem, let's just come up here to logistic regression and go max iterations equals, let's say 1,000, for example, if we don't want that warning message. Okay, so the warning message went away. All right, now let's show the confusion matrix result. I'm going to import confusion matrix display. And if you have an older version of Scikit-learn, you may need to upgrade that to use this one. And then accuracy score as well, PLT. All right, now I have my figure, and I'm going to go through each of my classifiers like I did before on the fitting right here. But now I'm going to generate a confusion matrix for each one. I'll do that with subplots. Because I have 8 classifiers, I'll do it in a 2x4 matrix of values just to display those. And I'm going to display them. You can see here I'm going to take the axis right here. I got the subplot. I'm going to put it right there in the index I for that. All right, and then also an accuracy score as well. And I'll print that accuracy score in a percentage format. And then I'll create the title. That's going to be the name of the classifier. And then save it as a PNG file for the confusion matrix. So there you can see the accuracies and the percentages. You see maybe the highest one in this case is a support vector machine. That was a 92.5%. The others did very well, very good as well, but except for stochastic gradient descent, and maybe the neural network as well. We may need to add additional structure to that network to be able to get that nonlinearity. All right, and then we can see the confusion matrix, and this just shows in a little bit more detail the accuracy. In particular, we had predicted labels and then the true labels. And so if we have high numbers right along this diagonal, it means it's very accurate and is doing a good job in the classification. You can see the off diagonal, we predicted a 0, but it was actually a 2. And so there is some of this, like up here, we predicted a 3, but it was actually a 0. And that's to be expected because we had some overlap even of the data. And these classifiers are trying to essentially draw the boundaries about where it thinks that A, B, C, or D should be. And sometimes when there's overlap, especially in the test data, even a perfect boundary would never be able to separate all of them. Okay, so here we have logistic regression. You can see stochastic gradient descent did very poorly on that one. Also neural network. Predicted label 2, had 0 predictions of 2, for example. And they were misclassified as 0 or 3. All right, so for our exercise, we're going to use adaptive boosting or AdaBoost. It's another machine learning algorithm for classification. And we're going to essentially take this one, just like we did on the other ones, and be able to add this, look at the confusion matrix. So if you'd like to just take this and copy it down here, that'll get us at least started with this. And you can see there's an error here. So I'm going to just generate the confusion matrix. I'm not going to predict it like this. Let's go ahead and just do something else here. I'm going to run this. Okay, so it fit the AdaBoost classifier. And now I'm going to use the confusion matrix display. And I'll say from estimator. And I'll have my AdaBoost classifier. And I'll take my test set with my X and my Y values. All right, and then for my labels, I have my Z values. So let's just see if this generates it. All right, so here's my confusion matrix display with the AdaBoost classifier, and let's take a look at the accuracy score. Okay, so accuracy score test with Z, and then use the AdaBoost predict. And here's where I'm going to use my test. Okay, I guess I didn't need my Z value in there. That was the problem from before. All right, so 60%. So it didn't do very well. It's let me just modify this on the predict. I didn't need the Z value right there. I'll modify that in the notebook. Okay, so there I have the accuracy score. Percentage would be 60.6%, and then my this is going to be my confusion matrix, and you can see that it didn't do a very good job predicting number 2. Okay, and that would be C. And so let's go back up and just look at C. All right, so C is going to be this red one. It somehow didn't do a very good job at predicting that. You can see if I add some more, those are the red dots right there for C. All right, so I hope you enjoy this interactive notebook. As I mentioned, there is the Google Colab, although you can't use the copy CSV to clipboard. You can download it, for example, but it makes it just a little bit more complicated. Okay, so come back to the course website if you'd like to get the notebook. There are also many other exercises here under applications. So this one is draw classification right here, but many other applications. If you'd like to take a deeper dive into classification and what each of the methods is doing, you can also take a look at this overview. And then we also have here the different supervised learning methods. So for example, if you want to go into logistic regression and code it up from scratch, there is an exercise here to help you understand exactly what it's doing as you can dive deeper into the method.